Welcome to Online Geometry Week 1. This is our day number 2 of the week. We're going to start looking at trigonometry ratios today and explore that for the next couple days. This is Mr. Natsky coming to you from his basement, making the best of the situation. I'm a little excited today that I'm getting back to teaching, and this is giving you guys the opportunity to learn. So, there's a video starting on Schoology. We're going to watch the video right here. There will be a link here. As of right now, there's not a link because I'm making the video. But once I finish the video, I will post a link here. You can click on that. It'll take you to YouTube, where you can open the video to watch it. If you have a printer at home, up on top here it says Print Blank Notes, where I've got highlighted. If you click on this link, copy of the blank notes will open up, and you can print them off so you can fill them out and follow along as you go. If you do not have a printer at home, then you can just take a blank piece of paper or a notebook, bring your notebook paper, and jot down notes as we follow through and go through this today. So we're going to start with 13.1, 13.2. This is an introductory to trig ratios. Before we start talking about trig ratios, sine, cosine, and tangent, we have to learn some terminology. And that's what our main focus is going to be today. So we start with the warm-up. We're going to draw a right triangle here in the coordinate grid. I'm going to draw one in here. Notice right here by the point 1, there's my right angle. And I want to label it X, Y, Z. I want angle Y here to be my right angle. Put angle X here at the top, and angle Z down here at the bottom. Then I'm going to find the lengths of all the sides. Well, notice YZ, since it's a horizontal line here, I can just count it. It's 1, 2, 3 units. So YZ is a measure of 3. I'm going to put a note there for 3. XY, which is vertical, which is right here, I'm counting. It's 1, 2, 3, 4 units. So that is 4. Well, XZ is not a horizontal or vertical line, so I cannot count that. So how am I going to find that? Well, it's a right triangle. Let's use the Pythagorean theorem. A squared plus b squared equals c squared. Let's let A be 3 and B be 4. So if you see down the bottom, I just click on it. It's 3 squared plus 4 squared. 9 plus 16 is 25. So I have 25 equals c squared. How do I solve for c? I need to take the square root. Take the square root of 25. Put the square root of c squared. I get 5. So xz here is 5. Then it asks me to use a protractor to measure the angles. If you have a protractor at home, you can get it out and use it. If you do not, it might be beneficial for you to get one as we proceed through our online here. So I'm going to turn my protractor straight up and down, measure angle X. My lines are pretty thick here. So if I look down here in the middle, I've got this nice little tool here, comes in the middle. I've got about 37, 38 degrees. Right now it's at 38. I'm going to write down that angle X is 37 degrees. Well, I know that angle Y is 90. If I come down here to measure angle Z, up a little bit more in the middle here. I've got about 53 degrees. Okay, now remember, we're measuring this by hand with a protractor. We're not always going to be exact, okay, but we kind of want to be close. We're going to come back to those measurements later on in our notes. Now, one other thing we remember before we proceed here is remember the relationship between sides and angles in a triangle. How do I know which angle's the biggest angle in this triangle, which angle is the smallest? Well, remember what we said is that the biggest angle in a triangle was always opposite of the largest side. The smallest angle was always opposite of the smallest side. So if I want to list the angles from least to greatest, well, the smallest angle is going to be angle B, because that is opposite of the smallest side, AC, which is 29 feet. Angle A is going to be the middle angle then, because it's opposite of what, say, the middle side, BC, which is 44. And AB being the longest side at 50 feet, well, angle C is opposite of that. Remember, opposite means across from it. Here, you can see it as I move my mouse. Okay, so angle C is going to end up being the biggest. So the smallest angle is angle B. Then we've got angle A, and then angle C. Well, today we're going to look and start 13. We're going to look at how we can use trigonometry with right triangles to solve real-world problems. Well, we're not going to get to that today. What we're going to do today is going to help us get there, and we're going to look at that next week as we start to do this. The essential question today and for the next couple of days is how can I use sine, cosine, and tangent in calculating involving right triangles? Well, we'll get there. How can I find missing sides? Well, we're going to get there. Maybe not today, but we will get there. One thing we have to talk about here, you don't have this in your notes, it's not in yours, is when we talk about naming sides. So if I have a triangle ABC, remember we would name angles with capital letters while we name sides with lowercase letters. As you see right here, I've got A, B, and a C. Well, side A is going to be across from angle A. Here's angle A. If I go all the way across from it, there's side A. Side B is going to be across from angle B. Here's angle B. I've got it over, go all the way across. That's the side that is opposite of it. And angle C right here is going to be across from angle C, which is our right angle. There it is. That is going to be key for us today as we start to name sides and label them. Math and careers. So detective uses clues to determine the time and place that an event has occurred. With the use of logic and math skills, a detective can pinpoint the time of day shown in a photograph based on the position of shadows in the image. One of the things they can use is trigonometry to determine that by looking at the photo, measuring some sides, measuring some angles, and going from there. And also involving similar triangles as well, which we talked about before spring break. Now, what we're going to do today was designed to be an activity. Here's our roles. If you want to go through it on your own, you can go ahead and go through it on your own. You don't have to watch the entire video, but I am going to go through all of everything for you together. So we've got our stamps, which obviously if you were in class, in the classroom, we'd be doing stamps for this, but we're not, so we won't from there. Well, you should know already how to label the sides of the right triangle. And we just talked about that. And we can then use the Pythagorean theorem of a squared plus b squared equals c squared. For a right triangle ABC, it is a standard procedure to label the angles with capital letters and label the sides opposite those three angles with small letters that correspond to the opposite angle. The hypotenuse is always side C, and it's always opposite the right angle. Well, what I want you to do right now is draw a triangle XYZ and label the sides with the proper letter. It doesn't tell us which angle is going to be the right angle. I have a triangle drawn here, a right triangle, so I'm going to label it. I'm going to put angle X here at the top. I'm going to let my right angle be angle Y, and then my other angle down here is Z. Your answers could vary. Well, where's side X going to be? So the blue letters are my lowercase letters. It's across from angle X. Angle Y then is going to be my hypotenuse, and Z will be across from Z. There we go. Very important that you understand how we label those as we move forward. Number 2, additional ways to label right triangles refer to the location of the sides with respect to the acute angles. As we talk about these acute angles and we start using these words to describe the location, we use the labels such as opposite and adjacent. For example, a side or leg that is adjacent to an acute angle, or a side leg that is opposite. Now, how do we determine opposite and adjacent? Well, it's based off one of the two acute angles. And you're going to hear me use the word a lot of the reference angle. Okay? And based off the reference angle, we will then determine which side is adjacent or opposite. So if I label my right triangle, where's angle A? It's across from side A. So the bottom left here, there's angle A. Angle B is going to be across from B. Here's side B. It's up here. And angle C is the right angle across from the hypotenuse. That one's pretty labeled. But what about these two boxes? What does it mean by opposite adjacent? How do we determine that? Well, let's think about what these words mean. Adjacent means next to. It means next to something. Well, for example, if I look at angle A is made up of two segments, correct? AB and AC are the two segments that make up the angle. Well, AB is the hypotenuse. So we're left with just one leg as the other side of it. Well, we're going to look at the segment, the leg, that creates it. That is what I refer to as the adjacent side, which as I look down here, so for example, side B here is adjacent to angle A. It's the leg. So whenever we talk about the word adjacent and opposite, we're always talking about the legs. Yes, the hypotenuse is next to angle A, but the hypotenuse is its own special name. And segment BC right here, which I'm moving my mouse up and down, that is the side that is adjacent to B. What does opposite mean? We kind of already covered this. Across from. Okay, it's a segment that is not one of the segments that create the angle. Notice segment A here does not create angle A. That is the leg or side that is opposite of angle A. Angle B, which is down here, the bottom one, I'm moving my mouse over, that's side B, that's opposite of angle B. It's the segment, that segment does not make up angle B. So those are two key words, adjacent, opposite, and hypotenuse. That is the number one goal that we have to get through and discover today as we proceed through this lesson. So we're going to look at some examples here. So when we want to look at here, we want to identify the side or leg that is adjacent to B, the side leg that is opposite of B. Well, I want to start out by identifying my reference angle. My reference angle, because the angle I'm talking about here is angle B. So I'm going to call angle B my reference angle. Well, I always then start which side's the hypotenuse. It's across from the right angle. Here's the right angle. Up here's my hypotenuse. Where's the leg that is next to then my reference angle, which is B? It's segment BC down here. So that's adjacent. AC is across from it. That's what I call the opposite. So which side or leg is adjacent to angle B? Well, it's segment BC. Which side or leg is opposite then of angle B? Which one's across from it? Right here. That is segment AC. And what's the hypotenuse? Across from the right angle. It's segment AC. Again, we could label these A, B, C, and go from there. As I look down at the next one here, I've got a triangle DEF. Well, where's that hypotenuse? Let's start there. Where's the hypotenuse? Across from the right angle. Angle F's the right angle. Segment DE is my hypotenuse. Well, I want to know which leg is adjacent to angle E. So angle E, which is right here. So right here is angle E. That is my reference angle. From that angle, I'm going to determine which leg is adjacent and which one's opposite. Which one's adjacent? Well, this segment right here. EF is adjacent. And that means DF here is across from it. That is my opposite side. The next example we got here is triangle DEF. Notice within this problem, my reference angle changes. Well, let's start out. What's the hypotenuse? Crossing the right angle. It doesn't matter which one my reference angle is. Segment ED is going to be my hypotenuse at all times. Now, the first two questions refer to angle D, so I'm going to call angle D my reference angle. Which angle is opposite of that 40-degree angle, which is angle D? Right here, it's across from it, EF. That means DF, which is down here in the bottom, that is my adjacent angle. Well, the next two questions, D and E, are talking about angle E. So angle E is now my reference angle. Which, I click here, notice my reference angle when I refer to angle E. I'm going to talk about that's now in blue. Which angle is adjacent to it? Well, EF was opposite of angle D, but EF is actually adjacent to angle E. So EF is my adjacent leg that's adjacent to angle E, while DF is opposite of angle E. Moving on to example number 4, we got triangle ABC here. We're going to find the measures of the following angles and sides. Here we're not going to find the angle measures. Well, we could find angle A is 64. We could find angle B. Three angles of a triangle add up to 180. 180 minus 90 minus 64 gives me angle B to be 36 degrees. We're not going to measure. We're going to figure this out. Which side's that hypotenuse? Where's that hypotenuse? Angle C is, right? Side across from it, it's 20 centimeters. Which leg is opposite of A? Right here is angle A. Which side is opposite? Across. Uh-oh. I don't know it, do I? Can I find it? Yes. It's a right triangle. What can we use? Pythagorean theorem. A squared plus B squared equals C squared. Let's let A be the side I'm missing. B is 8.8. It's the other leg, and that hypotenuse is 20. So A squared plus 8.8 squared will equal 20 squared. Take 8.8 and I square it. End up with 77.4. 0.44, actually that's a typo there. Should be 0.44 equals 400. Get A squared by itself. I'm going to subtract 77. Should be 44, not 40. Again, typo, 77.44. And end up with A squared equals 322.56. What do I do next? Got to take the square root. Square root of A squared, take the square root of 322.56, and I get 17.9599. Notice up above it says round to the 3 decimal places. Remember, with rounding, I always look at the third number. I want to round to 3. What's the number after it? Which is this 9, the second 9 here. If that number is a 5 or bigger, it tells me to round up. So I'm going to make I'm going to add 1 to the 9, which becomes 10, which actually will end up making this 17.96. Oops, I don't want to do that. Is the length of segment BC, which is the leg That is what? Opposite of angle A. Now, it says 3 decimal places. I got it written as 17.960. You do not, even though it says 3, if that number is 0, you do not have to have it. If you put it there, it's perfectly fine and acceptable as well. Which leg is opposite of angle B? Well, here's angle B. Which leg's across? 8.8. Remember, adjacent. D and E are asked for adjacent. Adjacent means next to. Which leg is adjacent to angle A? Here's angle A. Remember, we're talking about the leg. It's 8.8 centimeters adjacent. And adjacent to angle B is the side we had to find the measure of, which is 17.96 centimeters. Moving on to number 5. In this problem, there are 4 different right triangles that are given down below. Their measurements are given for you. This was set up for you to work in your groups. Each student would write the ratios. For student 1 would look down below. The first triangle. Student 2 would be the second triangle, the third, and the fourth. Well, if I just look at student 1, the first triangle, which angle is opposite? Which side is opposite of angle A? It's the 4.286 over the hypotenuse, which is the 7.472. If I write that ratio, and then I divide it using my calculator, I get 0.574. The next ratio it asks is adjacent, which measures adjacent to angle A over the hypotenuse. The adjacent side is 6.122 over the hypotenuse again, which is 7.42. Simplify that by just dividing it in my calculator, taking 6.122 divided by 7.472, and I get 0.819 rounded to 3 decimal places. The last ratio it asked me is the opposite side leg of angle A over the adjacent side. The opposite's 4.286. The adjacent here is the 6.122. Divide that out, I end up with 0.700. I've already got these filled in for triangles 2, 3, and 4. I'm going to click them. If you want to go through and try these on your own, go ahead and do them. Try them on your own, fill them out. You can pause the video and then restart it in. And that's what the ratios would look like. So if you can pause the video right now, you can go ahead and jot all them down. But the question is, we want to look at the questions B, C, and D down below. We're going to talk about these. When I look at these ratios, do you see a pattern? Yes, there is a pattern. Look at each row. The first row, even though there's 4 different triangles with 4 different measures, the ratio always simplified to 0.574. The second row, which is adjacent over hypotenuse for all 4 of these triangles, simplified to 0.819. And the third row, which is the ratio of the opposite side over the adjacent side, always simplified to 0.700. So compare the ratios. So if we're filling this out, the ratios of the 3 rows, the opposite over the hypotenuse, adjacent over hypotenuse, and the opposite over the adjacent, were all the same. Compare these ratios from those of your other teams. Well, the other teams, if we're doing this group, would all have the same things. So again, the ratios are the same. Well, why is that? Why can we draw this conclusion? Well, what it comes down to is, remember, the ratios were all equal for the different triangles, so the triangles must be similar, right? We actually have a side triangle similarity here. For all 3 sets of sides, had the same ratio. And if you divided the sides, you would see that as well. They all have the same, there's the same scale factor from one triangle to the next. And the scale factors will vary between the 4 triangles, but they are similar. And trigonometry is based off of that idea. We have similar triangles, and a lot of times we're going to get similar triangles based on angle-angle similarity, because what we're dealing with only involves right triangles. So it's got a 90-degree angle. And then if we got an angle measure, one angle, well, angle-angle similarity. In right triangle ABC, what will happen to the measure of the side lengths when the acute angle changes? Will the measures change? Yeah. The measures of these sides will change. Because as the angle changes, so will the sides. So will this affect the ratios then? Yeah, it will. Because when the side measures change, the ratio, when you simplify, will change as well. So if it was maybe 3 over 5, now it became 4 over 7. They're not the same ratio. Okay. Well, what we're going to look at in this lesson is we're going to learn that the ratios of side measures will define new terms in geometry called trigonometric ratios. That's what we're going to look at here. We have 3 trigonometric ratios: sine, cosine, and tangent. So if I've got a right triangle, triangle ABC, you've got the picture here, you see it, circling here with my mouse. The angles A, B, and C, and I've got the sides labeled opposite of their corresponding angles, side A, B, and C. Well, the sine, cosine, and tangent ranges for the acute angle A is as follows. That means angle A here is my reference angle. Okay? Well, which side is opposite of angle A? That's side A. And which side is the hypotenuse? That's side C. So the side opposite of the hypotenuse is side A over C. Well, that is actually the ratio for sine of A. It is read sine of A. Even though abbreviated it looks like sin, it's actually sine. Okay, it's the abbreviation, but we still call it sine. Cosine, okay? Well, cosine of A is going to be the ratio of the side adjacent to angle A, which is side B here, over the hypotenuse, which is B over C. That's cosine. Yes, abbreviated it's cos, but we call it cosine. Okay? It's just the abbreviation that we have here. Tangent then. Tangent's the ratio of the opposite side over the adjacent. So the opposite side of A, again, is side A. The adjacent side to angle A, or side or leg, is side B. So I have A over B. That's tangent of A. Even though it's abbreviated as tan, it is read as tangent of A. So we will use the abbreviations a lot, but do note we don't pronounce them by the abbreviations, so we use them as we go. So what I want you to do right now is pause the video. I want you here to try number 7 on your own for doing sine, cosine, and tangent of angle B. So again here, angle B is my reference angle, because that's the sine, cosine, and tangent that I want to follow. So pause the video, go ahead and try to fill these out. You probably should have restarted the video now. Remember, sine was the side opposite over the hypotenuse. Well, the side opposite of angle B is side B. The hypotenuse here is the side across the right angle, which is side C. So it's the ratio of B over C. Cosine up above was the adjacent side over the hypotenuse. Well, but now we're going to refer to the adjacent side of angle B. Which side is adjacent to angle B? That's side A. And that's over the hypotenuse. Which side is the hypotenuse? Again, side C. Tangents up above was the opposite over the adjacent. The opposite leg over the adjacent leg. Well, tangent of angle B then means going to be the opposite side opposite of angle B over the side that is adjacent to angle B. Remember, side meaning leg. Side B here is opposite. Side A is adjacent, so it's the ratio of B over C in this case. We have an acronym that helps us to remember this, and that term that we use is we call it SOHCAHTOA. SOHCAHTOA. Notice the first letters are S, C, and T of those three-letter words that really don't say a word, but they represent something. Well, the S stands for sine, the C stands for cosine, and the T stands for tangent. Well, why is it so? OH. And why is it Ka? AH and OA. What do O, H, and A stand for? Well, that's opposite, adjacent, and hypotenuse. Because sine is the ratio of what? Opposite over hypotenuse. So S sine of an angle will equal the opposite side over the hypotenuse. C is cosine. Cosine equals the adjacent over the hypotenuse. And tangent, TOA, refers to tangent. What is tangent the ratio of? Opposite over adjacent. So that acronym is used a lot to help us remember which sides go with which ones. As we proceed to number 8 here, this triangle looks very familiar. This is our triangle back from example number 4. And example number 4, we use the Pythagorean theorem to find the third side here, right? Segment BC, well, it's 64. What I want to do is write the ratios here for 64. 64 degrees is angle A. Well, so angle A is my reference angle. Remember, sine was so opposite over hypotenuse. Which side is opposite of angle A? 17.96. Which side was the hypotenuse? Well, the hypotenuse had a measure of 20. So sine of 64 is going to equal the ratio 17.96 over 20. I want to simplify that in my calculator, type that in to figure out as a decimal. It's 0.898 rounded to 3 decimal places. Cosine. Cosine is adjacent over hypotenuse. Which side is adjacent? 8.8 is adjacent. Remember that hypotenuse is 20, so it's 8.8 over 20. Simplify that as a decimal, divide it out, I get 0.44 is my answer. And tangent was TOA. Opposite over adjacent. 17.96 is opposite, 8.8 is adjacent, so I get the ratio 17.96 over 8.8, which simplifies to be 2.041. Number 9. I want to use the trig ratios to write the ratios for sine, cosine, and tangent of 23 degrees. Which angle is 23 degrees? Angle T. That's my reference angle. Notice I am missing one side. How do I find that third side? How do I get ST? What am I going to use? Pythagorean theorem. A squared plus B squared equals C squared. Let A be my missing side. 25 is B, it's my other leg, and 64 is the hypotenuse. Square both those numbers, I get 625 and 4096. How do I get A squared by itself? I'm going to subtract 625 from both sides. I have A squared equals 3471. What do? Take the square root. Square root of 3471 is 58.9151. Well, notice I want 3 decimals. So the 1 is below a 5, so it tells me to round up, so I'm going to leave it as 0.95. 58.915 is my answer. Go ahead, pause the video right now, and I want you to try these on your own. Welcome back. Remember, SOHCAHTOA, opposite, adjacent, hypotenuse. 25 is opposite of angle T, which is my 23-degree angle. It's my reference angle. The 58.915, that's the side that's adjacent to angle T. And the 64 is the hypotenuse. Why is it the hypotenuse? Because it's crossing the right angle. So, sine was the ratio of opposite over hypotenuse. It's 25 over 64. Divide that into type it in my calculator. Just type in 25 divided by 64. I get 0.391 as my decimal. Cosine of 23. Cosine's adjacent, which is 58.915, over the hypotenuse, which is 64. Type that into my calculator. 0.921. Tangent, TOA. It's opposite over adjacent. Which side's opposite? 25. What's the adjacent side? 58.915. Divide that into my calculator. 25 divided by 58.915. I get 0.424. What did they do before they had calculators? Because we're going to look at how we can find these using our calculator. Well, 700 years ago, The mathematicians spent years calculating these ratios for each acute angle in a right triangle by hand to several decimal places so that they could be used in astronomy. Up until recently, up until before calculators, people would usually look these values up using a large table, which was first compiled by the Greek mathematician Hipparchus, who is known as the father of trigonometry. The table below represents some of the trigonometry ratios in two different units, degrees and radians. In geometry, we're only going to focus on degrees. When you get to advanced algebra, you'll talk about radians and the radian measure there, and the conversion between the two. But we are not going to talk anything whatsoever about radians here in geometry. Our focus is going to be on degrees. If you do want, there's an entire table here. If you do go to Schoology, where it says table of trigonometric ratios, you can get this to print it off. As you do your assignment later on today, it is going to ask you to look at that table, so you'll need to at least open it up and take a look at it. Answer some questions in your assignment. Do you know the conversion factor from a radian to degree? Well, to convert from radians to degrees, we're going to take the radian measure and multiply it by 180 divided by pi. That's the conversion factor. We're not going to do anything with that. Just something nice to know. It's something you learn in advanced algebra. Well, we're going to look now at how can I find sine, cosine, and tangent of an angle using my calculator? Well, the first thing we have to do, because we're dealing with degrees, we have to make sure our calculator is in the right mode. If we do not, we will get the wrong answers every single time. Because I talked about there's two angle measures, degrees and radians. So what I'm going to do to do this first is I'm going to select the mode button. On the TI, it's this button right here. When I hit mode, the screen you see right here should pop up. You want to arrow down. If radians is highlighted, that means you're in the wrong mode. You want to arrow over degrees and hit enter so that it's in degrees. Once you did that, you can get out of there by just hitting second quit and getting back into it. So how do I get and type this in? Well, for example, to calculate sine of 67.5, okay, I'm just going to type in sine. I'm going to hit the sine button. Right here it is. And I'm going to type in the numbers 67, 67.5, and I'm going to hit enter. If I do that, what do I get? 0.924. How do I get cosine 67.5? Well, hit cosine. It's the COS button right here. Cos 67.5, and then hit enter. I do that, I end up with 0.383. If you have one of the TI-30s, if you have the TI-30s that I was handing out in class, the blue ones, they are just like the graphing calculators. You can type those in. Now, I will tell you this, is we did talk about, if you're on your Chromebooks, there's an app that actually allows you to get a TI-84. We have talked with IT. I think they're going to put that on your Chromebook possibly. It'll be an app for you, so if you don't have a calculator, you can use that to do it. But some of the calculators do require, I know, like the calculator on your phone. If you're using the phone calculator, or one of those that I always call the backwards one, you have to type in the degree measure first, then hit sine, cosine, or tangent. Last one here. So I want to do tangent 67.5. I'm going to hit the tangent button. Right here's the tangent button. Tangent 67.5. And then I'd enter. You'll end up with 2.414. What I want you to do right now is just try that. Type it in your calculator. I want you to type in sine of 27.4, sine of 27.5, sine of 27.6. We're going to talk about those numbers here, but go ahead and type those in. I did list them out here to 3 decimals. The angle measures do not change much. They only change by 1/10 of a degree. So will the ratios change? We said that if the angle changes, you said they would earlier. Well, they do change. Not very much. So what do you notice here? Are they changing? Yeah. So how can I show the change? Well, that's why we said you should round everything to 3 decimals, because if I just did it to 2, would you know the difference between these 3 angles? No, because they're all 0.46 to 2 decimals. So I have to go to at least 3 decimals in order to get it. That's why we're always saying 3. And as you do your homework and as you proceed through our trigonometry unit here, you should always be rounding to at least 3 decimal places. Think about it. If you want to know sine of 30, what kind of answer could you expect? Well, it's going to be a decimal, isn't it? It's a decimal less than 1. Why is that? Because the measure of the opposite side is always going to be smaller than the hypotenuse. The hypotenuse is the longest side in the right triangle. Well, if I take a number and divide by a bigger number, it's always going to be less than 1. Next question, if someone else draws a different right triangle with an angle of 42 degrees, will he get the same answer? Will his ratios be the same? As long as the angles are all 40, you both have an angle that's 42 degrees, yes they will. Because they're similar triangles. Angle-angle similarity allows us to do this. So now we're going to go back to our problem in the warm-up. Sine of x. Remember, sine is defined as the side opposite of angle x. Back to my warm-up. So which side was opposite of angle x? 3. The hypotenuse was 5. So it's a ratio of 3 over 5, which simplifies the decimal to 0.6. Well, cosine was adjacent over hypotenuse. The adjacent side of my warm-up was 4. The hypotenuse is 5, so I get 4 over 5, which is 0.8. Remember we said we measured angle x, and I said I had 37 degrees. And the reason I said 37 is because, well, when I measured on paper, I got 37. That's what I've got typed in here as I did this ahead of time. Well, let's type into our calculator, sine of 37. If I type in sine of 37, I get 0.602. If I type in cosine of 37, what do I get? 0.799. Notice the sine of the angle of angle x and cosine of angle x, they match those ratios. So how do I get them? How does the calculator get it? It's actually drawing a right triangle in your calculator, it's computing it, and finding the ratio of those sides. Now, do they match exactly? No. But do the side ratios match? We're going to say yeah, because they're close. I mean, if you round it to the nearest tenth, they are. I mean, it's the sine is 2 1,000ths off. The cosine one is 1 1,000th off, which human error, it's perfectly fine and acceptable. So in our closure, use the picture to write each trig ratio. Let's label our sides first. E, it's opposite of angle E. Side F is opposite of angle F. And the hypotenuse here is angle D. Remember, sine is what? Opposite over hypotenuse. Which side is opposite of angle E? It's side E. What's the hypotenuse? D. So I've got the ratio of E over D. Cosine is adjacent over hypotenuse. F is the adjacent side, D is the hypotenuse, so the ratio of F over D. Tangent, TOA, is opposite over adjacent. E is opposite, F is the adjacent, it's the adjacent side to my reference angle, so I end up with E over F. Sine, so now angle F is my reference angle. Well, notice now side F is opposite, and D is the hypotenuse, it's the ratio of F over D. Cosine of F, which side is adjacent? Well, it's E. Hypotenuse is still d, it's e over d is cosine of f, and tangent of f is the ratio what? Opposite over adjacent, side f over side e, it's f over e. Now let's try this with some numbers. I want you to write the ratios using the measurements 3, 4, and 5 here, and then find the decimal equivalents. Go ahead, pause the video, try them on your own. Welcome back. Sine of angle E, opposite over hypotenuse. Angle E is the reference angle, it's 4 over 5. Cosine of E, adjacent, 3 over 5. Tangent of E was opposite over adjacent, it's 4 over 3. The decimal equivalents. 4/5 simplifies 0.8 as a decimal. 3/5 is 0.6. 4/3 is 1.333 as a decimal. Now sine of f, cosine of f, tangent of f. Angle S is my reference angle. Which side's now opposite of it when I'm referring to angle f? It's 3. 5 still the hypotenuse. The decimal 3/5 is 0.6. Cosine of f, adjacent is 4. Hypotenuse is 5. 4/5, which is 0.8. Tangent, opposite over adjacent, I get 3 over 4, which is 0.75. Your independent practice assignment is a Trig ratios worksheet. Where can you find that? It's in Schoology. If you go to Schoology, remember this was day 2. My right column here is the independent practice. Intro to Trig ratios worksheet. If you click on this, the worksheet will pop up. You can print that off if you have a printer. If you do not, then just do it by hand on a blank piece of paper, answering those questions. After you've finished that, there is a Schoology check. How are we going to check to make sure that you're doing your homework and that you're paying attention here? Well, Schoology independent practice checks. We've been doing them all year. Up here, you see the Unit 5. Where my mouse is, highlighting right here. It's Unit 5 Schoology independent practice check. If you click either the arrow, they'll pop up here. This is day 1, day 2. It's 13.1.2 Intro to Trig ratios worksheet. Click on that. That will take you so you can enter your answers in Schoology. If you have any questions, remember, you can check the office hours up at top. Sign in to see one of the geometry teachers. It does not have to be your geometry teacher that you had. Whatever hours work best for you, go ahead and stop and check in with them. Ask any questions. How do you get to the link? Click on the link. As of right now, they will be up there when you look at this, but there's a link here. You click on that, it will take you to Google Hangout. A teacher will be there during those hours that you see on Schoology. And if they're not available, go ahead and send an email. Don't be afraid to contact your teacher. Send them. We're here to help you. You got to let us know what you need help with. Thank you for sitting through the video. I hope you have a good rest of your week and weekend. And I will see you next week.